All right, we're taking a look at 11.1, problem 25. Here they want us to draw u minus v. They give us the look of vectors u and v. I chose to do this in two stages here. First, I thought about moving vector v over so that its endpoint, or so its initial point matched up with u's initial point. And then from there, I thought about the sum of u and minus v. So here's minus v right there. So the sum of u and minus v would be this diagonal, okay, using our geometric interpretations. And so my last picture is actually our answer here, which would be the picture of u minus v. Problem 39. Here we're asked to find several things. All of these really go back to using some of our formulas. So I'm not going to speak too specifically here, but we're asked for magnitude of u, magnitude of v. We've been doing that for quite a while, so I think those are probably okay. We're asked for u plus v, as well as and the magnitude of that. So again, calculate u plus v and then find its magnitude. On D, we're asked for the magnitude of v divided by magnitude v, or excuse me, u divided by magnitude of u. And so u divided by magnitude of u is a unit vector. So anytime we ask what's the length of a unit vector, it's always 1. So D and E both are the same. They're both 1. And F is actually the exact same as well. We don't have to do any calculations for those because they're asking us for the length of a unit vector. Okay, number 47. Here we're asked to find a unit vector with a given magnitude and in the same direction as our vector u. So in this case, we're asked for the vector to have a magnitude of 5. And so the first thing that I did was I found the magnitude of our vector u, and then I knew that we could change it into a unit vector by multiplying by 1 over its magnitude. But I also knew that we wanted the final result to be to have a magnitude of 5. So here you'll see I multiplied by 5, and then I divided by square root of 5, because dividing by square root of 5 converts it to a length of 1. Multiplying by 5 scales it back out to a length of 5. And this is multiplying that by the vector u. If you'd like to rationalize your answer, here it is as a rationalized answer. I'm okay either way. Number 59, we're asked to think about the different parallelograms that we could draw given some points. We want to know the possible missing vertices. So there are different looks here. I didn't go through finding the points, but you just use some property of parallelograms to find the points. So the main thing is just to think about the different ways you could draw a parallelogram and then go about finding the point that would make it a parallelogram. All right, number 63. Here we are asked to find the values of a and b that satisfy this v equals au plus bw. So au plus bw, we would calculate that as a plus b and comma 2a minus b. And we also know already that v is 3, 3, 0. So we have some correspondences here we can make, that a plus b should be equal to 3, and 2a minus b should be equal to 0. That's a system of equations that we can solve. And so solving that, we find a is 1, we find that b is 2, and so the vector v is u plus 2w. All right, on number 73, we're asked to find the component form of v given magnitudes of u and u plus v and the angles that u and u plus v make with the positive x-axis. All right. So here we can write the vector u as magnitude of u times cosine theta I plus sine theta j. And we know in this problem magnitude of u is 1, so this is just 1 times cosine of 45 degrees, which we're also told is 45-degree angle, I plus sine 45 degrees j. Calculating cosine of 45 and sine of 45, you get square root of 2 over 2 I plus square root of 2 over 2 j. Doing the same for u plus v, you get square root of 2j, doing the exact same calculations with the given information. All right. Then we want to find the component form of vector v. We can rewrite this sort of algebraically: u plus v minus u. So u minus u is 0, of course. Putting in those given expressions for u plus v and for u, and just subtracting there gives us the following vector in component form: negative square root of 2 over 2 comma square root of 2 over 2. All right, number 77. Here we have 3 forces with magnitudes of 75 pounds, 100 pounds, and 125 pounds, each acting on an object at angles of 30 degrees, 45 degrees, and 120 degrees, respectively. We want to find the direction and magnitude of the resultant force. So writing each force vector, this is essentially magnitude, or the weight, and then again it's cosine of the angle I plus sine of the angle j. So we do that for each of those forces, those 3 components. And of course, the resultant force is the sum of all of those, so we're summing those up. The magnitude of the resultant force there is 225.8 pounds approximately. And again, that's just finding the magnitude of r. All right. Lastly, we're also asked for the direction. So we have the magnitude, we're asked for the direction. And so one thing we might do, and this is always the trouble with showing a way to do a problem. There's other ways you could come about finding this direction angle, but I thought about it as we could write the vector r, the resultant vector, as the magnitude of r times cosine theta I plus sine theta j, and that would indicate that we would have to factor out of the vector r. We would have to factor out the magnitude of r, so that we could write it in this form. And then that would, of course, mean that these terms here would have to be divided by 225.8, or approximately that, in order to do that. So that would mean that this expression here would correspond to the value of cosine theta. And so we just do inverse cosine there to find theta. Number 83, we have a plane flying with a bearing of 302 degrees. Its speed with respect to the air is 900 kilometers per hour. The wind at the plane's altitude is from the southwest at 100 kilometers per hour. And in your book, you have a picture of that scenario. We want to know what the true direction of the plane is, and we want to know what the speed is with respect to the ground. Looks like I have about 25 seconds left on my 10-minute recording, so I'm going to go ahead and stop this, and we'll pick up here with the second part.